idea here is really simple. We are looking at pieces of the seafloor that were made at the same spot between 7 and 61 million years ago. And we're looking at 5 different ages between those 7 and 61 million years, and looking at how the seafloor itself evolved, the microbial life that lives in the seafloor evolved, and also how changes in the sediments that flow on top of that volcanic seafloor have changed over 61 million years, including global climate and evolution of different types of organisms that we can track in the sediments and the chemistry of the seafloor.
We're drilling a series of holes at 15, 31, 48 and 61 million years old. So we're looking at how the crust is different as it gets older. And ocean drilling has in the past drilled crust of different ages in different places, but we're trying to do it systematically in one place so that we can just look at the effect of age on the ocean crust. And what we want to know is how long does water keep going through the rocks? How much of effect does that have on the rocks and on the oceans with time? How has this contributed to global chemical cycles, like the carbon cycle, for example? These veins that we're looking at here, these white veins, they're calcium carbonate. So this is a natural sink for CO2. That means CO2 from the atmosphere, which is being transferred into the oceans, is then being stored in these rocks. And we want to know how that process has varied with time as the amount of CO2 in the atmosphere has varied with time, because of course CO2 in the atmosphere is currently increasing, and we want to know what the effect of that might be.